These are the frequently asked questions for pre-calculus for section 3.3, day 2. And for number 61, it says, using the data in table 3.18, compute a logarithmic regression model and use it to predict when the population of San Antonio will be 1,500,000. Now, here's the key. To everybody that I've talked to about this problem today, so far it's been, people are using logistic regression on this. We haven't had to use logarithmic regression before, but we know it's on our calculator, so we just need to know, hey, let's punch this in and find that logarithmic regression. So I already have all of the data in here, and you'll notice on the fourth entry there that the calculator went ahead and put my 1,151,305 into scientific notation to hold that. And then we'll do stats, calculate, and we have to go down to number 9. All right, so there's number 9, which is natural log regression. And I'm going to hit enter. And I'm going to be using the first list, so second list 1, enter, and the second list. And I do want this stored because when we look ahead, they want us to give them some information about the graph. So I'm going to hit variables, y variables, arrow over 1 to the right. Number 1 for functions, number 1 for y sub 1, and then let it do its calculating here. So there is our regression model. Boy, is that quite a winner, huh? So we see that they give us y equals a plus b natural log of x. And the good news is they calculate a and b for us. And you know what, I'd be really tempted to use p of x for this one anyway, since we're talking about population. So we have for a negative 246461780.3 plus, and our b value is 325. $736.78.51 natural log of x. Now the good news is because I stored that with the y variables, I don't really have to do much with it. The calculator already has that in there. Now what they wanted us to do was predict when the population will be 1,500,000. So when I put my information into stats here, you can see that I just went ahead and used, let me get edit up here. I went ahead and used 1970, 1980, 1990, etc. So I need to fix my window here and realize that we're talking about years, like I said, from 1990 on. So maybe we'll try up to 2100 from 0. We don't even really need 0. We started at 1970, so maybe I will just use 1900 to 2100. And then I do need to know 1,500,000, so maybe 2 million. And then if we go into y equals, we'll see that it did in fact store that logarithmic regression for me, and I want to know, when is this 1,500,000 graph? So there is my logarithmic regression model. And here comes that 1,500,000. So second trace, number 5, hit enter 3 times. And we have 2022.998. So the year when that's going to occur, yeah, I'd probably just round and say approximately 2023. So as long as you get the correct regression, which is a logarithmic regression, then this one isn't going to be too bad. And a very similar situation, I'm sure, with number 62. The reason that people were not able to get this is because it is logarithmic regression. So that's going to be LN regression, which your calculator usually uses that capital letter for, so that it doesn't look like the word in, IN. So now I will stop the recording and get this new data in. A new set of data for this one, but it is the same regression that we were doing before. This is logarithmic, same regression we were doing in number 61. So all the new data is in there, stats, calculate, and again I want number 9, that logarithmic regression, and I do have that in list 1 and list 2, but variables, y variables, number 1 for functions, y sub 1, so that I don't have to type that monster in, and calculate. And there is our wonderful natural logarithm equation. So we have 5,636,088.18 plus, so we'll change that to a minus. That is a negative b value. So minus 733,749,0.871 natural log of x in our logarithmic regression. Now, what we want to do with this one is find out when the population of Milwaukee will be 500,000. So we're going to go into y equals. Glad to see that I have that brand new equation in there. And we wanted to know 500,000. And the years on this example were the exact same years that I had in the last one. So if I hit graph, I should get a good look at this. I shouldn't have to do too much tweaking. So there is the graph for Milwaukee, and there is the intersection, second trace, number 5, enter 1, 2, 3 times. And so we have 2024.4971. We round that down since it's less than half the year. So that's going to be approximately 2024. And remember, population, we're always talking about that July 1st cutoff for the census, so less than half a year. We're going to go ahead and round that piece down there. All right, next up, what do we have? And it looks like in number 62, somebody had asked for that one. I think you just forgot that common logarithm is on your calculator, because for this one, all we need is the logarithm of 2. So common logarithm and natural logarithm are already on our calculator. So we're going to come back into the calculator screen and just do the logarithm of 2. And we get that. Now, let's just say, for the sake of argument, although the instructions said you may use a graphing calculator to solve the problem, let's just say that you felt that was cheating somehow. Well, you could always snail shell this and say 10 to the what would give me 2. Well, it can't even be a 1 because 10 to the first is 10. So, process of elimination, that's out. 2 is really, really small. So that means that my decimal has to be a pretty small decimal. So that would mean this 0.69315 is out. And then you could go ahead and try raising it to the 1/10th power, the 2/10 power, the 3/10 power until you get the closest one. But again, this did say we could use the calculator, and that was what we should have gotten. Then we're doing inverses down here. And inverses, no matter what we're trying to solve here, involve switching the x and the y and solving for y. So what we're going to do here is we're going to go ahead and switch the x and the y. And we need that 3 by itself. So what we would have to do is divide both sides by 2 and get x over 2 equals 3 to the y. Now the reason we need that 3 to the y by itself is because we're going to need to take a logarithm base 3 of both sides in order to get y by itself. That's how we solve for y. So over here, we have logarithm base 3 of x over 2 equals y. Well, this is the inverse. So f inverse is the logarithm base 3 of x over 2, which was choice A. Right here. And that's it for the FAQs.